concentration of the species at equilibrium can also be determined if you're given the solubility product. Similar to before, the KSP for copper 2 sulfate is 1.40 times 10 to the negative 37 at 25 degrees Celsius. Calculate the concentrations of the copper ions and phosphate ions in a saturated solution of copper phosphate. First of all, the idea is to determine the concentration in moles per liter, so we'll work towards that. Secondly, saturated solutions are a must, otherwise the KSP would be really the reaction quotient. Anyways, the first thing to do is to bring up the balanced chemical equation. Determine the KSP expression, remembering that solids aren't included, which is essentially the reactants, and then we plug in what we know. So according to the rules, we're going to solve for S, and since the stoichiometry of the reaction is a 1 to 3 to 2 ratio, this is why these numbers are here. Also, the concentrations are raised to the power of their coefficients, which is why these numbers are here. Now we simplify it a bit more, which gives us this. Divide both sides by 108 to isolate the unknown. Square root both sides but with a 5, not really sure what you call it, to further isolate S, which gives us this. Now we can use stoichiometry to determine the individual concentrations of our products. The concentration of copper ions will be S times 3 because it's in a 1 to 3 ratio. Concentration of phosphate ions will be S times 2 because it's in a 1 to 2 ratio. It's that easy. KSP can also allow us to determine the solubility of an ionic compound. If the solubility is less than 1 gram per liter, it's technically insoluble. So, here's the data from before. The solubility of copper phosphate was calculated to be 1.669 times 10 to the negative 8 moles per liter. This needs to be converted to grams per liter, so we just need to convert the moles part into mass, which is moles times a molar mass, giving us 6.353 times 10 to the negative 6. Now this is well below 1 gram per liter, so copper phosphate is insoluble at 25 degrees Celsius.